Alright, I'm back with another lecture here for you. If any of you watched the Attribute Wrangle series, and specifically video number 2, you might recall at the end I had shown a quick little play blast, something that looks similar to this. It was of an expanding shockwave, as you see here, with some particles on the top leading outward of this explosion here. I'm now going to show you how you do something like this. I'm going to be giving you this scene file for download on the Ko-Fi site. Remember, you can go over there and download any of these lectures for free. You just have to go follow the link to Ko-Fi. That's where the HIP file's hosted. I'm going to give you this scene file, but we're going to rebuild it from scratch, not quite like this. As you can see, this one has displaced the ground, which is cool, but I'm going to show you a more common setup that is used much more frequently. We're going to do something more of just like an expanding dust ring shockwave. It's very common to have to do stuff like that, and typically you don't displace the ground, but you'll still have this scene file to look at on your own if you want to just see how it's done. So if you want to follow along with this, open up a clean scene file for Houdini, and we can start recreating something similar to that. So just hit tab and type geo. You always need some geometry node to work in. And now we're going to drop down a grid. Let's leave it at this default size, but let's give it a lot of detail here. 150 by 150. You'll see that gives us a lot more faces here to work with because we're going to be transferring color to this surface. And you can think of these rows and columns as the resolution of our color transfer. Now let's type tab and circle. Polygons is fine. Let's give this a whole lot of divisions. Again, something like 150, and let's look at it. Now we don't want it in this orientation. Let's change this to a ZX plane. So now it's facing the ground. You'll see it now faces our grid here. Now let's drop down a color node. Plug in. We're going to make this black. You might be seeing a familiar pattern here if you've watched some of my other lectures. Copy this over with the Alt and left drag. Like I've said many times, many Houdini rigs are set up with the same fundamental nodes. You'll find yourself using the exact same setup over and over again for rigs that might be completely different end results, but they will contain many of the same nodes and the same concepts. Now let's just drop down an attribute transfer. Plug our grid in on the left, our circle on the right, visualize it. Now by default, it'll be completely red, and that's because you have a transfer region of 10 units. Let's also just say we want CD to transfer. It's just by habit. I usually put that explicitly in. Now go over to conditions, and you'll see the distance threshold. You're going to want that to be much smaller. We might still adjust this later on, but for now 0.1 is fine, and now you can clearly see our ring. Now we're going to want to animate this to make an expanding shock wave, a little shock ring that comes out. So we can just drop down a transform node, wire it in over here. Let's template this so we can still see it. And let's make this 0 and hit Alt and left mouse click. Go into whatever you want. You don't have to copy these values exactly, but I'm going to go to frame 20 and do it again. And now go to frame, say, 60. And let's just expand this outward. And do Alt and left click again. You'll see now we have an animation. So let's go back and look at it here. Now that looks good, but you're going to notice that even when we have our scale at 0, we still get red in the center. That's because our points are still here. Even though it has a scale of 0, it's compressed them all down to the origin point 0, 0, 0, but they're still there and they're still going to transfer color. So all we have to do is, let's see, we want it to start here, do a keyframe on the translate Y, Alt left click, and then just back up to 1 and raise this up, and Alt and left click, and now you'll see when we hit play, let's enable our little clock here so we get the real-time playback and start over. You'll see now it comes on like that, so we don't get it there from the very beginning. Now let's drop down a scatter node. and plug in. Let's enable our point display here. And I'm going to turn off my grid so we don't see it all. And now you can see we have, by default, again, it does this relax iterations, which I don't personally like. You can turn that off. Let's also tell it density area. We just want to use CD, so capital C, lowercase d. And if we play forward, you see we get it just where our expanding red ring is. But you did notice, maybe, in the beginning here, before it starts to expand, we have points just scattered all over the surface. That's just a default behavior because the CD has no value there. And we can do something about that. Let's go down here, drop down a wrangle, plug in. We can say if at cd.x is equal to 0, remove point 0 at ptnum. Now you see they are completely gone. And then they come back once we get our red value, once our ring starts to expand, so that's exactly what we want. Hopefully you watched my wrangle lectures. It will explain all of this, so you should already know what this means. So now, think about this. We're going to be using this as an expanding shockwave here. This is going to drive our fluid emission. So we're going to want the velocity of this leading edge of points. Typically, we've been doing something like a point vel. And you can wire it in. And now let's just say central difference and enable your velocity vectors. And you'll see something that looks completely wrong. Let's look at it. Yeah, that is not at all what you want to see. Okay, these have velocity vectors going in all different directions. We want them to all be coming from a point and going back to the center because that will indicate that our velocity will be pushing along those vectors and making our pyro simulation spread outward. Right now, it would be a complete mess if we tried to use this point velocity node. The reason why that's happening is because it has a constantly changing point count, so it has no idea how to calculate the velocity correctly. But we can use another wrangle to save the day, like usual. Wrangles are awesome, and you should be very willing to use them. A lot of people don't like using wrangles. So I'll show you really quick how we can do that. We could do it in this wrangle, but we'll just drop down a new wrangle. And we can say, let's do v at v. A lot of times you don't need to specify a v in the beginning, but I like to just declare it so we know it's a vector. I mean, velocity is going to be a vector, so I just do v at v is equal to. Now we're going to use the position of each point. As you know, this code runs on every single point, and we are going to just subtract the bounding box center. Okay, so if we do get bbox center, and you'll see what it gives us here. It returns the center of the bounding box for the geometry. So the geometry is, of course, our incoming point, so you just use 0. And now click off. Now it might have been hard for you to see that on screen, but if you zoom in, look at what we get now. We get all these little lines going straight back to the origin. That's the center. Basically, because our geometry is centered on the origin, the center of our bounding box is also going to be the origin. So we get all these nice little lines going straight back. But this will work anywhere we move this geometry to. So that's what's very useful about it. As a quick example, we could have this and move it over here and here and see it still works. If you hard coded like the origin to this, it would not have worked when you moved it. So this is a way you can do proceduralism or automate your setup. Anywhere this moves, this would still work and calculate a velocity that's going to go outward from the center of the ring, which is exactly what you want in an expanding shockwave. Think about if you throw a pebble or a stone into a pond, that ripple is going to go outward. It's going to emanate from wherever that center point was, where the hit was, and that's exactly what we're going to try to replicate here. So if you notice, though, when it's very small, you have short little stubby velocity vectors compared to when it gets out to here. Look at how much longer those vectors are. You can't even see the arrows when it's here, and you see them very easily out here. So what would that mean if we ran this through a simulation? It would mean that we would have very, very little velocity pushing outward in the center here in the beginning of our explosion, if you will, if we want to consider this an explosion. And as we got to the end, it would have way more velocity. Now that's the inverse of what would actually happen. An explosion isn't going to pick up speed when it's getting farther and farther away from the explosion event. It's going to be very explosive and violent in the beginning and then lose speed as it goes outward. So we want to change this behavior. First thing we're going to want to do is normalize this value, this velocity calculation, and it's extremely simple. You just hit normalize and see returns a normalized vector. And at the end, we got to put our ending parentheses. Now, if you look, it actually shortened the length, but if you notice, let's zoom in, it's consistent the entire time. So these lengths are identical here as they are when they're out here. So that's great because now we have just basically the direction, and it's normalized, which means if you were to do the math to add up the 3 vectors of this velocity, it would have a magnitude of 1. It would add up to 1. You can Google normalized vectors if you have no idea what I'm talking about. There's countless resources out there on the internet, so there's no reason for me to go over it again. Now, what does this allow us to do? Now that we have these normalized, we can do some hand keying if we want. So we could simply do something like v at v times equals ch and just do vel mult. And if we click our little plus here, you know what's going to happen. We get a little vel mult here. Defaults to 0, which means our velocity will go to 0 because we're multiplying by 0. Any number multiplied by 0 becomes 0. Now you can see if we go beyond 1, you see them very clearly. We can change this range of this slider, as you know, or you should know from watching my other lectures. You can go up here. Let's say 0 to 10. And now we have a much larger range, and we can say, in the beginning, let's do anything. It doesn't really matter. You can do any number you want here. Alt and left click. And then when we get outwards here, we don't want any velocity really. We'll slow it down to something much smaller. And that's going to be good enough. Now, this is cool, but these are all extremely uniform. They're identical. They're just using the position of the point, going back to the origin, so everything is going to come out in a very linear fashion. We can do an attribute randomize. Let's zoom in here and plug in. Disable our point display. Now you can see by default it randomizes color, which we don't care about. So just change that to V and say, let's do add value, and then do a minimum value of something like, let's go negative 3, and max value will be a positive 3. Now you can see we get a much more noised up representation of this velocity. Now this might be a little too noisy for our likes here. So let's actually increase the overall velocity here so that we have more in the beginning. Now we could change this, or we could just simply do another line v at v times equals, say, 3, and that'll just globally scale up the entire velocity by a value of 3. Now our noised up values are more in line with the overall magnitude of this. And this will give us something much more interesting than just the linear version of our velocity when we don't have this noise on there. You can see the difference here. So now let's do a pyro source and plug on in. And we can say points. Let's say initialize smoke. It gives us density and temperature. But let's add an extra field here. You click this plus, doesn't matter. You can click the plus here or click the plus here. Only difference is when you click a plus over here, it adds the new attribute on top. If you click it here, it adds it down at the bottom. So it doesn't really matter. It's just up to you. Tell it velocity. That's all we want there. We want it to be velocity. And then we can do something like volume rasterize attributes. Plug it in. And we can say we want density, temperature, and V. Now, you might want to only visualize density. We're seeing all 3 fields right now, so it's kind of ugly. You could just say density, and then we only see our density value. This will be where the emission occurs. And now let's change this to something like 0.01 and say 0.45. We're gonna make our voxels more detailed, have a lot more resolution here, and reduce that particle scale a little. We might have to change these later, but for now we'll just lower them down to these values. This might actually be a little small, but this is going to be our source of our emission. Now, a more common thing to do nowadays is to use pyro right here at the geometry SOP level. It used to be, you drop a DOP net, wire it in, and then dive in and build your network in here. But they're trying to make people use it more up at this level, which has its pros and cons. It's a little more limited because it only gives you exposure to certain areas of the solver. So we're going to do it that way, though, because that's what a lot of people are doing these days. You could always dive in and modify things that you need if you really need to have more advanced control. But so if we just do pyro solver and plug into this first input, you can see it already calculates something here. So let's change a couple things. Voxel size, you're going to want to get this lower, but for now we won't go too low because it'll then be slow to play back. By default it's going to be sparse type, which is great because it'll be fairly quick. Let's look at collision, ground planes. Let's turn on the Y ground and we'll say close below 0. So it'll basically chop off the volume down here. It won't go below our 0. Sourcing, let's see what we have. We have density, temperature. We don't really care about burn. We're not going to use anything that needs burn, so you can disable that. Now let's just hit play and see where we're at. Probably going to need to change a lot of things. Yeah, you can see it's fairly sparse here, and I don't mean sparse solver. I mean there's not a whole lot of density. So a couple things we could do. We can go back up here and say, just increase this. Now you see you get a little more emission. I don't really like the buoyancy. It's going to have a lot of buoyancy to begin with here. So we can change this to say like 0.25. That'll reduce how much it rises up. Still might rise up a little too much, but you can see we got rid of that big central thing, that pillar that was rising up, so that's always good to get rid of that. We might have too low of a resolution. You can see very, very defined knobs here, or these lumps. So we're going to want to do a couple things about that. It also seems to dissipate very quickly, so let's, by default, that's at 0.1. Let's do something like 0.025. Dissipation just sucks out the density over time, so lowering that, it should make it linger around a little longer. Think about it almost like a lifespan as a particle. Let's also go under here to setup. Let's just increase this cache memory so we won't run out of RAM. And let's go over to our look. We can keep most of this here. I mean, fire, you could disable that. I mean, we're not going to make any fire in this. Let's go to our fields. Flame, again, we really wouldn't need flame. Let's look at shape. We can enable stuff like disturbance and turbulence. You'll have to do a lot of settings here probably to change this to do something that you want. But this will help break up the emission. Let's just see what by default, if it's visible. Default values don't seem to make too much of a visual difference. Let's go to turbulence. Let's increase this a lot. Increase the roughness a little bit. This is where you gotta get into it and just really go change every little setting and then play back and see if you like what you're seeing or not. We can change other thing up here, disturbance, block size. We can lower that, increase the roughness, increase the amount of disturbance. you can see it starts to get a little more detail. Now, keep in mind, we're also at a very low resolution here. You'd have to crank this up quite a bit. But overall, let's say, this is very uniform. It's very circular, so we'd want to do something about that. And we can go back up here, and we can change this in a number of different ways. I'll show you one way that's pretty simple. If we look at our transform node and hit W, you can see this is our circle here. And we got plenty of resolution, so we could noise this up. We could drop a mountain. And let's put it in before our transform, then it'll be consistent. We won't be moving through the noise field. And we can do a bunch of different things here. We can say, okay, like that's now obviously not circular, so it'll be a little more interesting. But if you notice, look at how crazy it is coming up and down off the surface. And if we look at our attribute transfer, now you see it only transfers in those very few areas where our curve is intersecting. So that wouldn't work at all. But once again, wrangle to the rescue. We could just put a little wrangle down here and say at p.y equals 0. Now you'll see it looks like it's the same. And why is that? Because we've reduced the p.y down to 0, which is great. That'll keep it on our plane. But by default, our mountain, see how it says noise along vector? The vector is n, that's pointing straight up. So let's disable that. Now you'll see we get an extremely noised out version of this, which we actually need to change. But you'll see it doesn't have anything up and down. If we disable our wrangle, it goes up and down. And then you don't get anything except for where those curves actually intersect the surface. So we absolutely need this wrangle on. But we do need to adjust our mountain. We can go down here, change the element size. Let's look at our amplitude and maybe make it a little more calm. That's still nicer than our spherical or circular nature. And that'll look nice. That'll give us a more disturbed edge. Now technically, if you really wanted to, you could copy this and let's wire it in after our transform and then disable this one. Now you'll see that it actually evolves and changes over time. You might want that instead. It's up to you. That could look cool, or it could actually introduce what would appear to be like popping along the leading edge. You would have to just see about your simulation how it turns out. But the reason why it changes when we add the mountain after our transform is because we're scaling this curve up in the transform. And then if we apply a noise after it, this is basically just think of it as a turbulent noise in our VOP that we usually do. It's going to be moving through the noise, and the noise is going to change as it's scaling up. So you would have to do it before your transform if you wanted it to be a stable, noisy edge, if you want this shape to remain the same. So it's up to you where you want to put it. I'm going to leave it above it for now because it'll probably be more stable. We can go back down here. Rewind, hit W so we're back in shaded mode, and hit play. Now you can see it's much more interesting and not so circular and linear, if linear is even the right word for that. But you will notice we get this rising plume, and the reason is because now we have a problem. Because we did this little trick of snapping it down all to 0, our animated transform in the beginning no longer works. So again, you could do a number of things to change this, or the simplest method is to just say, well, we know we don't even want it to start expanding until, say, frame 10. Is that even when we, let's see if that's when our expansion starts. Actually, no, it's around, let's say, 22. So you could just tell the solver start on frame 22, since we're not even caring about it before that anyways. So now you can see it doesn't have that plume in the center. So now it's a lot more interesting looking. Again, it's still very low resolution, so we would need more detail. Let's see, even up here, we can go to scatter, crank this up to like 8,000. Maybe even adjust our distance here, because you can see some gaps. Still some gaps, but you know, that might actually help break it up a little bit. Once you get like the basic rig down, which we could argue the basic rig is done, but then you're going to have to go back in and do a lot of noodling of values to try to make it just look the way you want it to look. You can see now it looks more dense. Now we could do some things to even randomize the amount of the velocity. Let's see, for one, if this is pushing ahead of this stuff here. Now it's leading pretty well in there, so let's just see what we could do though. If we look at our velocity values, let's see here, we could drop, say, a VOP and modify it a little bit. Go in, drop down a turbulent noise. P goes into pose. Change it to 3D, and we'll do 0 centered. And now we could just add this to our current velocity. So we're just going to modify the current velocity a little bit, plug it into V. And now let's increase this amplitude a lot so we can see it. Now you can see what I'm talking about here. And you would have to change this frequency. And you might want to do something like do a fit. Plug it in. And we can say our source minimum, let's just do -1, even though it might be a -0.5. But we'll do -1, and then destination maximum, you can say 4, 4, 4. Now you can see we get a wider range here. We could still change this around a little bit. Now this is going to give us some upward velocity, which might look cool. It might not. Again, you got to try these things out. So let's plug it in, see what it looks like. I'm just showing you the options that are out there for what you can do. Now we're getting a much more you know, unique behavior where it's not so circular and round. And I like it kind of how it rises up more on one side than this other side, so you can see how easy you can get that to look more unique. So if you were going to want to sim this, you know, much higher resolution, you'd go up here, voxel size, you could drop it down to say 0.01. Let's back it up. You might even want to increase this depending on your system RAM. This will be 25 gigs of RAM. My current machine has 128 gigs of RAM, so I could put this up to say like 75. And then hit play. And now this might take a bit of time here. Once we get simming, you can see it's way, way, way more detailed already. That could look pretty cool. I'm not going to play this out for very long, though. You might even be able to hear in the background my computer's fans are kicking in overdrive. They're starting to get more speed because the CPU is being taxed. I don't even know if, like, this is a sparse solve, so I don't even believe that uses OpenGL. I think that's all on the CPU. But you can see there's a lot more detail in there. Has some cool looking areas. Now let's look real quick. You could drop down a pyro bake volume, and that's a lot of times now how people are doing shading on these volumes. Smoke color, you could change that to something darker. You can modify this to your liking. That might be too dark, but once you get lighting in here, you know, we could just do some quick and simple point lighting just to try to make something look more interesting. You might even want one from the top. Dive back in. Now what's cool about this, we can just alt and left drag it over, and let's say, okay, I want this to be a cool fiery thing, so you have instant fire essentially. You'd have to modify this though to make it look like maybe an expanding shockwave of fire, so that's cool. You know, it's very simple to do something like that. I'll let it play out a little bit here. In the end, I might actually just skip ahead and we'll let this play out, but I'll wait for that. I want to show you one other thing here where you can modify the shape of the source volume that emits this stuff. This shouldn't take too long, but you can see how quickly you can make something look really cool. And I gotta tell you, I've done many shockwaves over the years. It's very common to have to do this. Now in the original Wrangle lecture part 2 at the end, I showed you the expanding shockwave that actually displaced the ground. That's also extremely easy to do. You're going to have access to that setup if you just download the file over on my Ko-Fi page. Remember, the files are completely free. They're just hosted over on Ko-Fi, so that's where you have to grab it from. So that's pretty cool. Big old ring of fire. Now, like I was saying, though, we can go up here and let's see where we did our conversion. Here we go. Now this is pretty boring and bland. It's all completely spherical. That's the way this works when it converts these things, but it's very simple to noise up your volume. If we middle click it, we know that density is our first volume, so that would be an index of 0. That's going to come in handy when we go like this. We could do, let's do a volume VOP, plug into our first input. Working inside a volume VOP is just like all the other VOPs I've shown you, so we can drop down to turbulent noise, say 3D, 0 centered again, and let's do position into position. Now let's do add, and we're going to add our noise to our volume's position. But now you can't just directly plug it in like this. You see, that does not work. So you got to do something a little different. If you type tab and do a volume sample, and just pick the first one, not vector. The reason is we're not sampling a volume vector value. That would be something like velocity, like a 3 float. Density is not a vector, so we're going to use the standard volume sample. Plug the sum into the sample position. Say first input, because that is our incoming volume. Primitive 0, because we want to affect our density, and that is what the density is stored in, our 0 grid of this volume. And plug in, and now you'll see it shifted a little bit, and you can see we can change it like so. You can change the frequency, the roughness, everything that we normally do, but you might get some areas that clip. So it might be hard for you to see this, but this is a hard edge clip. The reason is because we are displacing our volumetric data, but we're not expanding the volume, so it's kind of hitting a wall, like it doesn't have anywhere to go when we displace it. So you can just do a VDB activate and wire it in before our VOP, and if we just go expand, you can see it already moved a little bit, but say expand it by, say, 10 voxels. And now you can see it expanded it out, but it still clips a little, so just go a little higher. Still clipping a little bit, so go a little higher. And now it looks like it's pretty good. You don't want to expand this too much. It just depends on your source volume's resolution. If this was like a very high res, like 0.0005 voxel size, and you try to expand by a lot of voxels, it's going to add potentially hundreds of millions of voxels to your volume, and that would not be good. So now we can plug this in, and here let's escape that, because that's going to play up to all the way to 49. Let me just reset that, and now I'll hit play. This is still the high res setting, but that'll help also break up your shape a little bit, because now we're not emitting from such a uniform volume. So I'm gonna let this play out for a little bit, and I'm gonna pick up the video after it's gotten like 30 or more frames. Alright, so that's done, at least it's as done as I'm gonna let it go. It took a while to sim it, but you can see some pretty cool looking results here, very quickly done. And of course you could go crazy with the resolution just depending on your system's hardware. Now let me just show you a couple other things here before we wrap this up. I know it's getting a little long here, but I want to show you just a couple more things. If you wanted to animate this thing turning off, a lot of times people like delete the source points up here, but that's not a great idea. When you delete these source points, you're also deleting the source of velocity that's pushing it outward. So a lot of times you'll see it expanding, 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 and then just stop and start rising up. So if you did want to animate this thing, I would say go into your pyro solver, your sourcing, and then animate this density scale. Let's go to manual mode so we can scrub the timeline here and say you could go to frame just 35, alt and left click, and then go to frame whatever 42 and bring it down to 0. Now the density will stop emitting over this range, and then you'll just see it dissipate and start to, you know, fizzle out. That's the way I would do it. Let's re-enable this to auto update. One last thing I want to show you, actually, if you dive in here, we can go and do something like add a gas damp. Okay, so that's gonna give it almost like some wind resistance, some drag. Let's go back up here. Let's reduce this voxel size, or actually, you know, increase it so it's not as high a resolution, so it'll play back a little faster, so we can see this a little more interactively. First, we got to go up here, pin this view up at this level, then we can actually see what we're doing. Let's rewind. Increase this damping scale. Hit play. You'll see it starts to leave more of this smoke trailing behind. It's not expanding outward as much. So that's one thing you can do. Let's actually maybe turn off the pyro just because it's a little hard to tell what's happening with that fire, but you'll see now it like lags behind. There's other really cool things you can do in here. I don't want to make this video much longer, but if you did like a gas, let's see, an axial force, plug that right into here, back up. Now this is gonna look at the little icon. It gives you a hint it's gonna be an axial force, so it's gonna rotate around. So we could say, let's see, endpoint, yeah, all this is fine. Let's do influence distance. We'll increase that because that'll be how far it influences outward. And do an orbit force. Let's do high speed here, strength, and who knows what that's going to look like. Might have to modify that a lot, but you can see it start to spiral a little. You could do global strength, higher distance, higher strength. Just throwing numbers out there. Don't worry about copying these. I'm just trying to show you real quick how cool some of these forces are in here. You could easily make a cool spinning smoke effect. This could be the entrance, like a portal to another dimension. Anything you can think of, you know, it's like really cool and looks really awesome when you start getting all this textural detail or this turbulent detail. I'll pick this video back up after this plays out a little more. So if we just play this back, you can see the spinning vortexy look. And let's see, that probably looked pretty cool on fire. You'd have to adjust your fire parameters to get it back in there, but, you know, it could be a pretty cool effect. So I'm going to disconnect this, though. I'll leave it in here just so you can see it in the example file. Mostly the gas damp is what I wanted to show you in here. So that's just a quick overview of how you can make expanding shock waves very easily. Now there's a lot more I could show you about this, but this is just a quick introduction to it. I might do a full like mini lecture or something, but that would be only over on the Ko-Fi subscribers page. Remember, the subscriptions are different. If you're a YouTube subscriber, that is not the same as a Ko-Fi subscriber. Ko-Fi subscriptions are paid, starting at $3 a month, very low. YouTube subscribers are completely free. If at some point enough people subscribe to this YouTube channel, I'll be able to make everything free, because then advertisers will actually float the bill. But YouTube has a policy: you can't even attempt to monetize a channel until you get at least 1,000 subscribers. So that is a long way to go for a channel that was just launched. But if we ever get there, I will be able to give everybody everything for free, as long as we just get more subscribers. So if you liked what you saw, hit like, hit subscribe, and you can help make all the information free for everybody. With that being said, that's the end of this lecture, and I will see you in another one.